Welcome. In this video, we'll be discussing how to do fraction multiplication. You can find this on page 20 in your ALEKS notes. Unlike addition, with fraction multiplication, you actually don't need common denominators. So to discover why, let's take a look at an example. So the example that I have is 2 times 3. And if you think about how multiplication, the process works, well, if I were to represent 2 times 3, what that would mean is I would start with two objects. So let's say that those two objects are two squares. So, and then times 3, well, what that would mean is that I have 3 groups of those two objects. And so remember, the way I could represent that then is I would have 3 groups. There's one group. There's the second group. And there's the third group, which gives me a total of 6 objects. But keep in mind that the things that I'm adding, these objects, all come from this first number. So I don't have to worry, in this case, about adding things that are not of the same size and same shape, because these two objects are always referring to the same type of object, the same size and same shaped objects. So when I'm doing 4/7 times 9/10, well, again, since I'm working with fractions, I always want to have a referent in mind. If you didn't have a chance to check out videos from topics 14 and 15, go back and do that. But whenever I'm working with fractions, I always want to have a referent in mind. In other words, what is 4/7 referring to? What is 9/10 referring to? Well, in this case, because it's multiplication, I really only need a representation for 4/7. The 9/10 is going to tell me how many groups I have. So the 4/7, the way I'm going to represent that is, well, if one whole looks like this, I have to break that whole into 7 pieces. So I've got 4/7 is going to be shading in 4 of those pieces. So I did cheat a little bit because I realized that I only broke it into 6, so I actually extended my whole by 1 piece. But bear in mind that this is still just one whole. And what I've shaded is just 4/7 of that whole. Okay, and now what the 9/10 represents, again, is it's not a separate object like it was in addition. What it represents is really the number of groups of this particular set of objects that I have. So when I'm doing multiplication, it's actually a 2-step process, and it's kind of nice. So let's take a look at this particular example. So we've got 4/7 times 9/10. So the first step in multiplying fractions together is I'm just going to multiply the tops. Okay, the second step, and I'm going to keep this as step 1, is I'm going to multiply the bottoms. So I multiply tops and multiply bottoms. So I've got 4/7 times 9/10 equals, well, if I multiply tops, 4 times 9 is 36. 7 times 10, if I do the bottoms, is 70. So I get 36 on top and 70 on the bottom. Step 2 in the process is just to reduce what I've got. So 36 over 70. Well, if I divide top and bottom by 2, I think that it's going to turn out to be 18 over 35 will be my final answer. So really, with multiplying fractions, a really important nugget is that you do not need common denominators. Because we're not adding things together that are not of like size and shape. Okay, I want you guys to try number 2, so pause the video, and then after you've given number 2 a try, restart when ready. So for number 2, again, if I just multiply across the top, that will give you 10. Multiply across the bottom is 24. If I reduce that answer, divide both top and bottom by 2, that should yield 5/12. Okay, then give 3 and 4 a try. Pause the video and then restart it when ready. So number 3, if I multiply across the top, 15, multiply across the bottom, 36. Okay, and I think both 3 goes into both 15 and 36. So dividing 15 by 3 is 5. Dividing 36 by 3 is 12. So we get 5/12 again. And then number 4, 5 times 6 is 30. 16 times 20 is 320. And I'm going to use a little trick. Here I see that both numbers end in a 0. What that means is I can divide top and bottom by 10. So if I divide top and bottom by 10, 30 divided by 10 is 3. 320 divided by 10 is 32.